Okay, welcome y'all. Hopefully you are here for COSC 365, Programming Languages and Systems. So welcome. My name is Brad Vanderzanden, and I'm happy to have you call me Brad. If you do not feel comfortable with that, Dr. Vanderzanden works, Dr. Brad works. It's all good. Your worshipfulness. No, just kidding. So this is a survey course that covers a variety of different programming languages. One of its primary goals is to introduce you to Java. It's the one course in our curriculum that really gets you acquainted with Java. It's a bit of a fast ride, I will admit. We spend about the first 5 or 6 weeks of the semester on Java, and then we transition to a number of other topics in the class. So if you're wondering what it is, we're basically going to be covering Java for about 6 weeks. Then we have a bit of a segue. So this is Programming Languages and Systems. So we move on for about 2.5 weeks to Information Management and Retrieval. Now this used to be GUIs, and I wish it still were GUIs. However, our good friends at ABET, which is our accreditation organization, recently revamped their curriculum guidelines. And they say that as part of the required curriculum for computer science, you must have a brief introduction to information management and retrieval. This is the logical course in which to put that introduction, because we have programming languages, but we also have and systems. So information management and retrieval, you'll be learning, it's kind of a systems-y thing, although you'll also be given a brief introduction to the language SQL. You'll also learn a little bit about HTML and XML and JSON. So I'm kind of sad about the fact that we can't do GUIs, because that is my research area, but it is what it is. So after that, we move on into Python, and from there we go to concurrency, but we'll be doing it in Java. So that'll be kind of nice. How many of you are also taking 360 this semester? That's fantastic. The reason it's fantastic is because at about the time we get to concurrency, you will also be getting to threads in 360. So you will be seeing two different approaches to threads. The high-level approach taken in Java, and the lower-level library pthreads approach taken in C. And in fact, the programming assignment that you'll be given for concurrency, the big one will be something called JTalk, where you will be implementing a talk program using threads. Who's teaching 360 this semester? So you may not be doing the JTalk lab in 360 this semester. One of you might check and tell me whether that seems to be toward the end of the semester or not. At any rate, sometimes, I know Dr. Plank always has the JTalk assignment. I'm not sure if Dr. Wong will or not. At any rate, it's kind of neat because you see two different ways of doing the same problem. And then we end with everyone's favorite language of all, and if you can't hear the sarcasm in my voice, then that's what it is. So functional languages will be a real mind-bending experience for y'all. It's important that you be introduced to them because they are actually out there in the real world. In fact, the most widely used language in the world is a functional language. You just wouldn't realize it. And that would be spreadsheets. So spreadsheets are actually a functional language. It's just not something that you might realize, but when we get there, I will tell you why. So those are the 5 main topics that we'll be talking about in this course. Now, with Java, there's actually some language features that you'll be seeing that are also in C++ and C, and we'll be comparing and contrasting those language features. And some of them you may have had a passing experience with, especially if you've gone through the 140 and 302 sequence with Dr. Greger. For others, you may not have had as much experience with some of them. So what I'm talking about here is we'll be going through things like inheritance and module mechanisms, exception handling, and generics, which in C++ is templates. And those are things that you may have had, as I said, maybe some experience with, maybe you haven't had a lot of experience with them. With generics, you've all used templates. You may not have had to actually write a template class. Okay, again, with Dr. Greger, I assume those of you who've had Dr. Greger, did you do the templates, actually write a template class?
Yes.
Those of you who took Dr. Plank? No. Okay. So for some of you, it will be somewhat familiar. For some of you, it will not be. Okay, and that's just a difference between Dr. Plank's and Dr. Greger's philosophy. So you'll see that in this course. So basically, the first 3 to 4 weeks, you will have a quick ramp up in Java. Then we will start looking at inheritance, module mechanisms, exception handling, and generics. And when we do that, we'll actually be looking at how those same things are implemented in C and C++, because many of you have not seen how those things are also implemented in C and C++. Okay, so this class is a nice survey of a lot of different things. It's meant to bring you up to speed with different kinds of language paradigms. So in this class, you'll be much more exposed to object-oriented programming. You'll be exposed to scripting languages. You'll be exposed to functional languages. You'll be exposed to some languages used in information management and retrieval. And you'll also, at times, get to look beneath the hood, so to speak, at how certain language things are handled. So for example, Java uses garbage collection. We'll take a look at how garbage collection gets implemented, some of the common algorithms for implementing garbage collection. When we get to inheritance, we'll be talking about something called virtual methods. Don't worry if you haven't really heard about them. You will get to hear about them, and we'll talk a little bit about how they get implemented. So you'll see a little bit also about how certain language features get implemented. So that's the big picture about what we'll be discussing in the course. So any questions thus far? Okay, so let me take probably about half an hour or so to talk about the logistics of the class, kind of my philosophy toward teaching in this class, and then at the end of the class, we're going to actually start getting a bit into Java already. So first thing you need to know is where to find information. And I'll make sure that I get this course up on the department's course website. So there's a place I know somewhere that the lab staff maintains links to various courses. But the quick way to get to everything you need to know is using this link right here. And that is a 6. Okay? So that's a handy one to write down. And let me go to it. So you will see there's my office hours. Been told in the past they're hard to find. Hopefully can't make it any clearer than that when they are. So right after class on Tuesday, and then 3:15 to 4:15 on Wednesdays. So in here you can find information About the course, so course information. That's going to include my contact information, the TA's contact information, how to compute your grades, some other stuff I'll show you in just a moment. The lecture notes for the course, which has assigned readings, my lecture notes, example code. So it often helps when you're doing assignments to be able to look at code someone else has created. So we have that. Then the link to the homework assignments. Now you'll submit the homework assignments on Canvas, but you will be finding them following this homework link. Then we use the Piazza discussion board here. I don't use Canvas for discussion, so you will need to use the sign up link to sign up to Piazza, and I would encourage you to do that as soon as possible. I don't mind if you do that right now while you're listening to me. Eventually, there will be some sample exams up, but for the time being, the important dates are Tuesday, March 5th and Wednesday, May 1st, which is when there will be a midterm and a final. And I won't go through the plagiarism policy in detail, but basically you need to submit your own work unless I tell you otherwise. So you will each be working individually on your assignments. Sometimes in class, as I'll get to, you'll be able to work with a partner on a problem, and in that case, I'll let the TAs know to expect that. But please don't, in general, sit down and code with someone else. It's fine to discuss a problem in general terms, but if you actually sit down together and start writing code, chances are the TAs are going to flag it as plagiarism, and we just can't tell who did what. First time, you'll normally get a 0 for the entire homework assignment. If it happens again, you'll get an F for the course, and I'll have to refer you to academic conduct. Hopefully that doesn't happen. So work needs to be your own. If you find it on the internet, that's not your work. Okay? Has to be your work. Now, if I give you example code or stuff in class, it's fine. That's fair game. Okay? But stuff you find that someone else did on the internet, that's not fair game. Okay? So it needs to be your own work. And then when you're getting started, it can sometimes be a bit bewildering with a new language. So there was a person who created a nice set of common error messages and runtime error messages. And I know it's old 2007, but Java has not changed fundamentally since around 2000. So you still get the same error messages and runtime errors now that you got 10 years ago. So you start finding yourself having difficulty interpreting an error message that you get from the compiler, because as we all know, they are incredibly clear and precise always about what's wrong. Okay? So if they're not as clear and precise as you would like, this is a very nice guide that gives you more background on what the compiler is trying to tell you in its clipped fashion. Okay, so I'm going to go through each of these links in a bit more detail. My philosophy is this class will be a mixture of lectures and a flipped classroom. Later in the semester, it will be more of a flipped classroom where you'll be working on homework assignments while I provide help. Earlier in the semester, it's going to be more lecture heavy. Okay, so later in the semester, I find that the homework assignments are a little more difficult. I also know that you're under more time pressure, and it helps to be able to work on those assignments in class. I also know students frequently get stuck, and it's easy for me to come around and get you unstuck. The analogy I like to use is that of golfing, because I'm a big golfer, and I can tell you that you can watch video after video about how to swing the golf club, okay? And Tiger Woods will make it look easy. Jack Nicklaus will make it look easy. And then you'll get out there and you'll swing, and the ball's down there still. Whoops, missed the ball, as you said. Okay? So the problem is, it's easy to listen to me. It's easy to listen to Tiger Woods or Jack Nicklaus. But you actually learn by doing. Typically, you don't learn by listening. And later in the course, when we get into things like Python and concurrency and functional languages, it's very easy to listen to me and say, oh, that sounds reasonable. And then you start working on your homework assignment and you're like, goodness gracious, I don't have the first clue how to get going. Okay? And my office hours are Tuesday and Wednesday for an hour each. That's not great. So, I mean, it's good, but Tuesday and Thursday in class I've found where I can circulate, see what's going wrong, and try to get you over the hump unstuck quickly. I found that that helps a great deal. So my being there, helping you, I know where the pitfalls are. You could easily spin your wheels for a couple hours on something, get nowhere, or you could be here in class and I could get you over that hump in a couple minutes. So I've found that having students work on the assignments in class later in the semester works out very well. I've also found that generally it's a bit better to lecture earlier in the semester. Okay, so you will see if you go to lecture notes that one thing I have is whether attendance is mandatory. Later in the semester, attendance becomes mandatory. Early on, no, because some of you already know Java pretty well, and I don't really need to be boring those of you who know Java to tears. Okay, so early in the class, you'll see that no, no, no. Then we get to inheritance. I don't care if you've had Java before or not. I want you here for those inheritance lectures because my experience is students struggle with inheritance. Okay, then we go to module mechanisms, generic functions, exception handling. No. Okay, then the introduction to information management. I'll want you here. But again, some of you know HTML and XML and JSON well. Some of you know databases well. But then once we get to Python in the second half of the course, so starting about mid-March, the rest of the time, attendance will be mandatory. So you can see for the last 11 lectures, attendance will be mandatory. Whereas earlier in the semester, except for the inheritance lectures, attendance is not mandatory. Okay, so I don't have dates. Instead, I have number of days that are devoted to each topic. So you can see today, we're introducing the course, giving a quick introduction to Java. For the first part of the course, I have an online textbook. We'll be giving it a try this semester. I'll be very interested in your evaluations to hear whether it's worth keeping the textbook or not. We're using the Xi book, which works very well in CS 140. It's an electronic textbook. It should be accessible through Canvas. In the course introduction, I'll show you how you can get access to it in a moment. The Xi books, what I like about them, they're short and concise. They don't spend a lot of time blabbering away about things that you don't really need to know. They focus on the most important stuff, the old 80-20 rule, which is that 20% of the effort gets you 80% of what you want to know. The remaining 20% of what you need to know takes 80% of the effort. And I think that's often true of textbooks. So Xi books, they're short, succinct to the point. I like that. They also have interactive exercises that come to me via Canvas. I can make Canvas assignments and see whether you've done them. The exercises have two purposes. First, academic studies show that if you engage with the material via exercises as you're reading, you tend to retain it better. Secondly, that gives me some assurance that before you've come to class, you actually read the material. Okay? It helps if you've read the material before coming to class. So I assign these readings, and then I expect you to also do the participatory activities, not the challenge activities, just the participatory activities. So up here, it goes through that. Okay, when there are assigned iBook readings, there are also, you're responsible for completing the participatory activities. Okay, and those are due before class. I make them due at 12:30. Okay, not 12:40, 12:30. They don't take that long. Okay, and as I said, it helps you prepare for class. I also have videotaped lectures. So this was actually the intro lecture from 2 years ago. I'm taping right now. I'll upload today's lecture later today. I also, in the past, have gone through and created short lectures about different topics. So if you don't come to class, feel free to look at these different lectures. They're short, to the point. You have the times next to many of them. Feel free to speed them up. They're all on YouTube. You can, using YouTube, accelerate the audio. I find I sound good at about 1.5 times normal speed. In fact, studies again show that we speak too slowly, that the human mind can process material faster than we can speak. And the general rule of thumb is at about 50% if you're a native speaker, meaning that generally the best learning they've found occurs at 1.5 times. Seems that if it's at 1 time, people actually start to get bored because you're not moving fast enough. Okay, so I'd actually encourage you to speed them up. So if you miss a lecture, don't worry. Just look at the posted online lectures. Okay. You'll notice I don't yet have lectures for the information management part because I've never done it before. So those ones I'll be lecturing in class and then posting them afterwards. Okay, so again, in the past I would say you had to look at these lectures ahead of time. Not this time. These are just good supplements to what I'll be talking about in class. Later on, when we get to the Python and concurrency, that's not in the textbook. Then I'll actually be wanting you to watch these videos before you come to class. Why? Because in class you're going to be working on the assignments. Okay, so I'll go over some of the quick important points at the beginning of class, but for the most part, you'll be getting what you need to know from those pre-recorded lectures. And they're not 1:15. I know that they're generally about 30 minutes long. Okay, if you speed them up, it's 20 minutes. It's not like it's a killer for you to prepare 20 minutes to half an hour for my class, especially when you're working on the homework assignments in class. But that's later, okay? That's not early in the class. Questions about that? Okay. Course information. So I'm in MinGal 312. We have 2 TAs for the class, but they'll primarily, these are not their office hours. I've told them to get me their office hours, so I just was too lazy to remove the office hours from previous semester. This is also not their offices yet, but this is their correct email addresses. They will primarily be responsible for grading. So if you have questions, please either see me in office hours or go to Piazza and post your questions there. I prefer you only send me personal questions via email. Generally, if you have questions about homework assignments or subject material, other students have that same question. Okay? I found that if one student has the question, probably 10 have it but are afraid to ask it. So please post your questions to Piazza. That way, when I answer them, everyone sees the answer. Okay? And that's where I'll be making my announcements too. I make my announcements to Piazza. The TAs will also have office hours, but primarily you'll want to see them about grading issues, especially early in the class. I've told them if something doesn't work, just give you a 0, and then you can come back during office hours and show them what you did wrong, why if you just correct that one little thing it works, and then they can give you all the points back. But this isn't like 102 or 140 for them. It's not easy for them to scan your program and figure out what went wrong, okay? So if something's not working properly, it just takes them too long to have to figure out why your program's not working. It's a lot easier, presumably whatever you submitted worked for you, or you wouldn't have submitted it. So if you get a 0 and it says it doesn't work, see the TAs during their office hours, show them why it works on your machine, that it works on your machine, and you'll get most of your points back. Okay, I found that works well in the past. So don't panic when you see a 0. Just go and see the TAs during office hours and say, look, it worked on my machine. Here it is. Okay? Now, I will say we do want things working on the Hydra machine. So please try to make your stuff work on the Hydra machines. The reason I say that is Java is notorious for having different versions of its virtual machine. The one on the Hydra machines is a 1.8 version. But unfortunately, if you develop in a more recent version, say a 1.9 version, and you use a feature that's not supported in 1.8, it will crash on the Hydra machines. So that's why we want you running stuff on the Hydra machines. Make sure it works, okay? Like I said, class attendance, sometimes it's mandatory, sometimes it's not. Look at the class lecture notes to see whether it's mandatory for that day or not. And there will be these short 5-minute Canvas quizzes at the end of the class to see whether you attended or not. They're incredibly hard, the quizzes. They say true, false, I was here. If you answer false, well, sorry, you won't get credit. Okay. So the reason, again, I make class mandatory, I find that, A, when you're later in the semester, with the best of intentions, you're just falling behind. That's when all the projects fall due. So the temptation to skip is high. And I found that the students who skip tend to do worse than the students who attend. Second, I think that having you here working on those homework assignments and me being able to get you over the hump is a pretty good payoff. If I can save you 2 hours of spinning your wheels with a couple minutes, that's pretty good. So it's one of those, a penny saved is penny wise, pound foolish if you skip. Okay? You save a penny now, but you'll waste a pound or 2 hours spinning later. So I just find it easier to say you will be here later in the semester. Okay? As I said, the one required course is available through Canvas is the Zyanti textbook. I'm not sure if you have to enter this code or not, but if it prompts you for a code, there it is. Okay, so when you go to Canvas, you go online, you'll need to enter this Zybook code, UTK. Just out of curiosity, has anyone tried to access the book yet through Canvas? Can you all try now? Give you a little break for those of you who have one. Go to Canvas, go to CS. First of all, make sure that I actually have published the Canvas website. I see some nods, so that's good first step. Okay, you used the code and got the book. Fantastic. Okay, pardon? Well, not really, but you paid for it. But yeah. Okay, good. So if you don't have a computer now, it's under course info, and you should be able to use that code to get access to the book. Okay. So, by the way, I understand that sometimes those participation activities are going to seem tedious. I also know that they've done their research and published it in peer-reviewed journals and conferences and found that they get about 2/3 of a letter grade improvement. Okay, which is the same letter grade improvement I've gotten in 102 by flipping the classroom. So you may find some of those activities tedious, but they do drive home the point. When I first got here, one of the professors used to have a model that I liked. He used to say that repetition is the key to learning. And why is that? Because repetition is the key to learning. Okay, so yes, some of the participatory activities will seem a bit repetitive, drives in the points. Okay, there are some other useful things. So I used to require this textbook. I don't require it anymore. You can probably get it for $10 somewhere, especially the 3rd edition. If you really feel like you have to have another reference, there it is. I think my lecture notes are pretty good. I think the online tutorials are pretty good. So once we get away from the textbook in the second half of the course, I think you can rely on my notes and the websites I suggest in order to understand the material. But if you really feel you need a textbook, here it is. I would get the 3rd edition. I'm sure it's cheap. Okay, so that's the one I recommend. You will make extensive use of the Java API in this course. It is next to impossible to keep it memorized. We will be using Java version 8, not 9. Why version 8? Because that's the version that's running on our Hydra machines. Besides, at this point, I think they essentially stopped making big innovations around Java 5 or 6. At this point, they're just adding some pretty esoteric stuff to the standard. Okay, so if you go to it, what you'll see is this kind of handy-dandy thing. And for every class, wow, there's a lot of classes. Look at all those A's. Okay, let's go to a linked list. Okay, there we have a linked list. And you click on it, you get the description for a linked list, which has what it extends, what its superclass is, some interfaces it implements. Don't worry about all that yet. It has a description, a short description of what that class does. Then the thing you really care about is a description of the constructors and a description of the methods you can use that are public. Those are the things you'll probably need to use the API documentation for. Generally, the easiest way to find it is to Google it. Okay, if you Google Java version 8 API, look at that, the #1 hit. Okay, so you'll be using that a lot. And the Java tutorials, if you don't like what the book has to say, the Java tutorials also do a very good job of presenting various things. Like getting started is just like what the Java basics are. Also learning the Java language then goes through various object-oriented programming concepts, classes and objects, blah, blah, blah. In fact, as we get more away from the textbook, like when we get to concurrency, I'll actually have you reading the Java tutorials. These are all posted by Oracle. However, Sun really gets the credit. They were the ones who actually devised the Java language, and then Oracle acquired Sun some number of years ago. So those are the useful websites. Then everyone's favorite, My Grade. So attendance will count 5%. The pre-class Zybook activities will count 5%. Look at that. Attendance should be free. It's like I'm going to require it 15 times during the semester, and you can get 5% of your grade just by showing up. How easy can that be? Then the pre-class Zybook activities. That's another one. There's no reason to be leaving points on the table here. If you get it wrong, by the way, you can correct it. Okay? There's really no reason not to get 100 on these things. Then I have after-class quizzes. Why? Because reviewing material right after class has also been shown to significantly improve learning. And I know y'all are busy, and the easy thing to do is to put off reviewing the material until the midterm or the final. But if I can make you review the material quickly within 48 hours, that's good. So I give short quizzes on Canvas, none today, but they'll start on Tuesday. And they're short. They're normally 5 to 10 multiple choice, multiple answer questions. And as long as you've been to class and read the Xi book or the material I assigned that day, you should be in good shape. Okay, and the quizzes are also great preps for the midterm and the final, because I ask a fair amount of multiple choice, multiple answer in those. The homework assignments are 30%, the midterm and the final 25% each. Final is not comprehensive. It's like a midterm. It covers everything for the second half of the course. Okay, so the quizzes, they're not Blackboard. I have to correct that. They're Canvas quizzes. They are available at 2 p.m. the day of the class. They're due by 12:30 a.m., 48 hours later. So for Tuesday lectures, they're due right before class on Thursday. For the Thursday lectures, they're due on Saturday. One exception, today, there are assigned participatory activities, and of course, I don't expect that you finish them before class today. They are due Saturday. So you do have one brief assignment after class today, and that is to get these participatory activities done by 12 o'clock noon on Saturday. Okay, it won't take you long. And then these are due by next Tuesday. Okay, so you do have a couple early assignments, not too hard. Yes. Is there a link for those? Yes. Yes. So if you go to, thank you for asking. So if you go to the CS365 Canvas website, you will see, if we go to the bottom, pre-class activities. If you click through on that, you'll get to the ones. Please do that because it makes my life a lot easier. Okay. Yep, and because it automatically transfers the result to Canvas. So you'll find them in either modules or assignments. Just go to the very bottom. You can see they're all published and available for you. In fact, you can do them early if you want. There's nothing stopping you from doing them whenever you want. You'll see later in the semester I'll be doing attendance. Here's the quizzes. Okay, you can see, again, there's nothing that you need to do until next week on the quizzes. Don't worry about them. I publish homework solutions 2 days after they are due. And there's the homeworks. These are just for submission. Okay? If you want to see the homework assignments, you go back to the homework link, which we'll get to. Okay, but just going back to course info for a moment. Mm-hmm. Really? Okay. Let me very quickly do something. I bet I know what it might be. Now try. I think that Canvas, even though I published everyone, I didn't publish the module. There we go. Thank you. That's what always helps. Okay. I think that worked? Okay, great. Okay, make sure everything else, the quizzes are published, everything else is published. Great. Okay. Okay. So, now, next thing, I drop your 3 lowest quiz grades. So please don't let me know about how you didn't get a quiz done, and could you please get an extension? No, you can't. I dropped 3 quizzes to handle this situation. You forgot. You were busy. You were sick. You were on vacation. You were at a conference. Okay, I understand. Stuff happens. So I throw out the 3 lowest quizzes. Okay, so I won't give you an extension because I throw out the 3 lowest. Okay, there's only 29 or 28 sessions in this class. So you should be able to hit 25 out of the 28. Okay, now I also get questions about how I can get extra credit in the class. It's easy. Hand in your homework early. Okay? So, if you submit, actually this is outdated. If you submit your homework more than 24 hours in advance, you will get 5 points of extra credit. If you submit it 48 hours in advance, you will get 10 points of extra credit. So if you want extra credit, you can get up to 10 points by just submitting it 48 hours early. Now, if you resubmit, the amount of extra credit you get, if any, will be based on your final submission, the timestamp of your final submission. So, I'm not going to let you submit problem 1 48 hours early and then submit the rest of it, on time and get your extra credit. No, it's based on the timestamp of your last submission. But I found this is great. First of all, you get extra credit in a fairly easy way. Secondly, it helps to get you going early so you don't procrastinate. I find out if there's problems with the homework early and can let everyone else know about it. It just seems to be a win-win. Now, you're also allowed to submit your homework assignments up to 2 days late. Each day is 10 points off. So the first day, 10 points off. Second day is 20 points off. Okay, after that, you don't get to submit it. Okay, because I want to post the solutions. Okay. So, questions about any of that? Yes?
For our attendance, will we need a clicker for attendance?
No. I do a Canvas quiz. Okay. It's that true false, were you here or not? Okay. Yes?
And that extra credit only applies to the homework, not the pre-class activities, right?
That's correct. It only applies to the homework. I have no way, actually, of really easily seeing how early you did the pre-class. Other questions? Okay, so let's see. Make sure you sign up for Piazza. Just a quick look. So you get grading guides. So you actually get to see what everything is worth. Sometimes the grading guides aren't all that informative, but sometimes they are. And you click through and tells you what you need to do for the homework assignment. So submit those homework assignments on Canvas, but you'll find them on the course website. And you'll find when they're due both on Canvas and here. Now, notice I make them due at 6 a.m. So when it says it's due Wednesday, January 23rd, it's really not. It's due Tuesday evening. For those of you who are night owls, many of you are, I let you work all the way through the night. Okay, I'm not a night owl. If you think you're going to get a response from me at midnight on January 23rd, you would be mistaken. Okay, so some other student might be able to give you clarification, but I can't. So effectively, when you see these, deduct 1 day from when they're really due. They're really due the previous evening, but you get to work all the way through until 6 a.m. Okay. You're welcome. I know, some people really, when I introduced this about 5 years ago, the first couple of times in the student evaluations, I had students just really loving it. So sadly, I don't get that love anymore, but I know, now it's expected. Okay, what else? I think that pretty much covers it. Got the Zybook. Got the homework, the lecture notes, course information. I think we're good. Okay, so I'm going to take about 25 minutes. By the way, one of my pet peeves, that clock and my computer differ by a minute. I believe my computer, not that clock, okay? So when that clock says 1:55, my computer says 1:54. I go by my computer. So it may seem that I go over by a minute or two, but according to my computer, I do not. Okay? So, just telling you that. Okay, so just going to spend about 25 minutes going through Java. And basically, Java is like C. It was based on C++. It was meant as a simplified C++. I will leave it to the book. Section 1.7 tells you the history of the language. So it's just fun to read what the history of the language was. It was essentially meant to be a language for set-top TV boxes, the kind that now sit on your TV, but it was before its time in the 1990s. Okay? They didn't catch on for about 15 years after that. And essentially what they did was this hot new thing came available called the World Wide Web. And Sun quickly pivoted and repurposed their cable box language for the internet, and it worked. So it became very popular, in part because it turned out that while business programmers could not learn to use C++, it was too complicated for them, they could learn how to use Java. So it turned out that at about that time, Smalltalk was becoming popular because C++ was too hard for business programmers to learn, but Smalltalk wasn't. And then lo and behold, here came Java, and it fit a perfect spot in the market. So Java is essentially a simplified version of C++, developed roughly 10 to 15 years after C++ was developed, and they knew what all the warts were in C++, and they did their best to remove them. So they simplified pointers. They did a lot of other things. So the first part of this course goes pretty rapidly. You'll see that 3 lectures, including this one, devoted to Java basics before we slow down a little. And you'll see, oh my gosh, through the first part of the course, you're all the way up to chapter 7. But notice I've cherry-picked it. So a lot of what is not in here is exactly similar to C++ and C. Java's for loop syntax, just like C++. They're while loops, just like C++. Do while, just like C++. If then else, exactly the same syntax. Variable declarations, the same syntax, except for Boolean. Okay, C++ uses bool, Java uses Boolean. Otherwise, same syntax. Okay, so that's why I've cherry-picked. Where I have assigned you readings is where they differ. And there are important differences. So in the first 3 lectures, what I focus on is what is different about Java than C++. I do not focus on the similarities because there is a great deal that is similar. Okay, so let's look at our first Java program. And you'll notice something very different immediately, which is that main is inside of a class. So the first thing, the first big difference between Java and C++ is that everything, all functions go inside of classes. There are no standalone functions in Java. Even main goes inside of a class. Okay, and it has a very specific signature, just like it does in C++. That is what you will write verbatim. Well, you don't have to write that, but then the Java compiler doesn't have to recognize your main either. Okay? So unless you write it exactly like that, your program won't run. Okay, you'll see there's something else different about main. What else is different? I highlighted it. How does that differ from a main in C++?
We just get one args array instead of RCRV.
Very good. There's only one argument rather than 2. Essentially, Java only uses argv. Okay, but they don't call it argv, they call it args. Just like C++ has its idiomatic nomenclature, so does Java. In Java, the argument array is traditionally just called args. You only have one. The reason you don't have argc is that in Java you have the ability to query the length of an array using .length. So if I say args.length, that will give me the length of the array. So I don't need argc. There's a second difference. Does anyone know the second difference about command line arguments? Yes.
Or just pertaining to main, also normally the main instead of static.
That is true. So that's different. But I was wondering about command line arguments.
Isn't it because it's a string and not a character?
No, there's still, I understand what you're saying. That's true. The declaration is different. It's a string, not a char double star. Very good. That's another difference. There's another difference that you may not know unless.
There's a third optional argument in C.
Okay. I don't know what it does either, so that's not it. Yes. Okay. Okay. So I don't think Java gives us that option either, but that's an interesting one. Now I learned something new. Thanks, Emily. Okay. So the other difference is that the arguments that the user provides start, ooh, don't do that. Start at arg0. User provided arguments. Okay, in C++ and C, they start at 1. What is 0? What is argv0 in C++ and C? The executable name. Okay, Java assumes you know the name of the class. Whoa, it's right there. Okay, they assume you know what it's named. So they start their arguments at 0. So the first argument the user provides is accessed in arg0, not in args1. Okay? Now, you can, if you want, go ahead and write everything in main. I don't suggest you do that. I suggest that you use this style here where you call the constructor and you put everything that you would normally put in main in the constructor. I will show you why in a moment. Okay, for the time being, here's our classic hello world system.out.println. So Java uses libraries just like C++ does, and you, in this case, need to name the library. So this is the system library. .out is the output stream. Println prints whatever string you give it, and then a new line. If you just said print, you would not get a new line character. So println says, print that on a line, and then output a new line character after it. So that is hello world. The way we compile it is with Java-C. Now, we typically name our files the same as the name of the class. We also typically only put one class per file. These are pretty standard Java guidelines. So one class per file. File name has the same name as the class. This is really important for Java because the way it turns out that it locates classes is by looking for files with that name. So if you go and name hello world bvz.java, it won't be able to figure out where hello world is. Okay, so you name them the same. You use a .java extension. You compile using Java-C, and it compiles it into a .class file. So when you're done and you type ls, you should see hello world.class. And this file is a bit like a .o file, except that it contains something called bytecodes. So Java compiles into something, the bytecodes are something akin to assembly language. If you look at the standard, the bytecodes look a bit like assembly language. And originally, these bytecodes were then interpreted using what was called a virtual machine. So this virtual machine is a software implementation of a physical machine, except this physical machine does not exist. And this virtual machine implemented in software works on any platform. So You can run it on Windows, you can run it on Unix or Linux, you can run it on a Mac, and the virtual machine looks the same, has the same API everywhere, so your .class file should run on that virtual machine on any operating system, which makes Java very portable, which was important when it was introduced because if it was downloaded over the internet, who knew what type of machine it was running on? So it was really important that these class files be portable. So these bytecodes come down, and originally they were interpreted. Now that's pretty slow. In fact, the original Java programs were about 10 times slower than comparable compiled C and C++ programs. These days, the programs or the bytecodes are further compiled and optimized using something called a just-in-time compiler, or JIT. Stands for just-in-time compiler. So basically what happens is you download the class or you start running it, and the Java virtual machine invokes a just-in-time compiler which will try to compile those bytecodes down into machine language for whichever architecture you're running on. So in fact, these days, Java code tends not to be interpreted. It tends to be compiled into machine language to the best of their ability. When you use, well, let's actually do this. Let's go and actually run a program. So, make sure I have it. There it is. Let's compile it. You may have to download the current, some version of Java to your machine. Shouldn't be that hard. I assume by now you all know how to download and install stuff. I strongly urge you to download Java to your machine and develop your stuff locally rather than logging into the Hydra machines. Now, if you want to run it, you have to invoke the Java virtual machine, and you do that by typing Java. So unlike C or C++, these are not standalone. The .class files are not standalone files. They cannot execute. You have to hand them to a Java virtual machine. So by calling Java, it invokes the virtual machine, and it compiles those bytecodes and runs your program. You'll notice you give the name of the class containing your main. That's how you get it to run. Yes?
You said that it compiles to best of its ability. Does that mean there's some code that it still has to interpret?
It means that I am not super familiar with their compiler technology, and I'm hedging my bets. My guess is that because they dynamically load everything, that they might start interpreting it immediately and then in the background compile, and then they will subsequently compile. So my guess is that initially to get things going, they interpret, and then as soon as it's compiled, they start running the compiled codes. But I'm not 100% sure. Michael Jantz would know for sure. He's our compiler guru. Okay, so if you look at the version, oh, come on. There we go. You see something called hotspot. So, hotspot compilers are an improvement on just-in-time compilers. So hotspot compilers are looking for places or code fragments that are executed very frequently. Essentially, the virtual machine is constantly monitoring the performance of your program. And when it sees that a certain fragment, such as a loop, is executing a lot, that's called a hotspot. And it will further try to optimize the performance of that hotspot. So normally, you just get perfunctory optimization. But if it sees, the hotspot compiler sees that some part of your code is getting hit a lot, it will go to a much higher level of optimization. In C++, when you compile, you can specify the level of optimization like O1, O2, O3. I'm not sure how high the level of optimization gets in a hotspot compiler, but I know it will go to greater lengths to optimize that code. Effectively, you get code replacement, inline code replacement, where it will replace whatever code is there with this newer, more highly optimized code, and it will do it dynamically. Okay, so a hotspot compiler incorporates a just-in-time compiler. The just-in-time compiler will give you a pretty good compilation. Then as your program executes, the hotspot compiler keeps watching. It sees something executing a lot, and it will go to work in the background trying to optimize it even further. So that's why if you ever look at the version, you typically now see it's a Java hotspot trademark because it is a Java, or it was pretty much commercialized at Sun. Okay, questions? Ah, yes. Feel free to use them. Yep. Feel free to use IDEs. In fact, with Java, I think that IDEs make your life easier because it's a lot easier to navigate your code, and it's easier to find the definitions of the API, essentially. So all for it. The only thing about it is when you submit your homework assignment, make sure it runs without the IDE, because the IDE will sometimes inject its own. I know NetBeans does this. It injects its own files, and that's a pain in the neck. Okay, yeah. So you used to get a rant about how much I hated IDEs, but then when I started using Java, I realized how valuable they were. And quite frankly, IDEs are used in industry all the time. So if you get used to them, more power to you. Okay. Don't include the .class suffix. If you include the .class suffix when you invoke the Java virtual machine, it won't work. It won't find it. Okay. Notes about style. Why did I say you should put everything that would normally go in main into your constructor? I explain why. So here's a very simple program in C++. It sums 3 and 6. It multiplies 9 and 5. It returns what the sum is. Okay, it's very simple. Okay, here's how I think you should write it in Java. So you put the code that goes in main into the 0 argument constructor, and then just like in C++, you have your other functions. Notice that the functions can go after the point where they're used. It's not a problem. No function prototypes. Yay. Okay, so it doesn't matter whether functions go before or after where they're first used. Okay, and effectively, Java's using what would be called a 2-pass compiler, where it makes 1 pass to see everything that you declare, 2nd pass to see where it's being used. Okay, so you decide, hey, why don't I just code this up in Java the same way I would do it in C++, so I'll put it all in main. Let's give that a whirl, okay? So here it is, written just like I would do it in C++. So everything is in main, and I try to compile it. Whoops, error messages. All drat. Non-static method sum cannot be referenced from a static context. This is the killer. So the problem is, anytime you're running in a static method, and main must be declared static, it means it's what's called a class method. Static methods do not take instances of objects, i.e. this variable that you may or may not be accustomed to does not exist in a static method. So when this static method tries to call sum, sum is not static. Sum expects an instance of the arithmetic object. That object doesn't exist. When you call a static method, it does not create an instance of that object. It's like calling a global method. So no such instance exists. So if you tried to call sum, you need to have an instance of the object. When you're calling it from a static method, that instance does not exist. All you can call from static methods are other static methods. So in order to make this work, you would have to declare sum and multiply as static. Okay, I can do that. Okay, and this should work now. Okay, but it's a horrendous pain in the neck to always remember to declare everything static. It just becomes, I mean, especially as you get more complicated programs, it becomes a mess. It's just a lot easier and tends to be pretty standard in Java if instead of doing it this way, you do it this way. You just in main, you create an instance of arithmetic. In that instance, or in the constructor, you put your main, and now it's fine to call all the methods in main that you want, and you don't have to distinguish between static and non-static. Okay? I'm not going to bust your chops for doing it the other way. It's just I really prefer, actually I may bust your chops. I think in the first homework assignment I say you have to do it my way. Okay, so I'm Frank Sinatra. No, Frank Sinatra said he'd do it his way. I'm saying you all will do it my way. Okay, at least once I would like you to do it my way to see how it's done. Okay, so let's just look at now some of these major differences. So I have this C++ versus C. I wouldn't necessarily look at this until we've gone more through C because this is a nice summary. But until you know something about Java, some of what is said in these notes about C++ versus Java, you may not understand. Okay? But let's just go to the environment issues. So we've already told you Java doesn't compile its code down to machine language. It compiles it down to bytecodes which are run on a virtual machine. So that's the difference between C++ and Java. Okay? Because of the bytecodes, Java's architecture neutral, so it makes it easy to port a Java program to another machine. Now, you used to hear them talk about, oh, Java's portable everywhere. You just compile it once, it runs on every machine. Except then it crashes. You think, why did it crash? And the reason is, as long as you run it on a virtual machine that is a version at or higher than the one you compiled it on, it will run flawlessly. So if you compile it using a Java 1.6 compiler and you run it on a Java 1.8 virtual machine, you're all good. But if you compile it on a Java 1.8 compiler and try to run it on a Java 1.6 virtual machine, it may crash because Java 1.7 and 1.8 may have implemented features that aren't supported on a Java 1.6 virtual machine. So they should change their advertisement to your code is portable as long as you run it on a virtual machine whose version number is greater than or equal to the one you compiled it on. Then we're good. We all got that? Because that's a pretty important caveat that they never bother to mention. Okay. So the Java virtual machine also provides a good deal of runtime checking that you cannot get rid of. So think of C++ as a race car, stripped down, fast, without a lot of those safety features you would like. think of Java as that luxurious Mercedes-Benz, slower, but if you get in an accident, going to protect you. Okay? So, what are some of the examples? So Java does a lot of runtime checking. Every time you access an array, it does array bounds checking. If you try to access a subscript outside the bounds of an array, it will throw an exception and terminate your program. If, you can catch it, a little bit of a lie. We'll get to that. It will type check your downcast. C++ will say yes, yes, yes. We take that downcast as gospel. Java won't. It will say, okay, you're downcasting from a list to a linked list. Let's make sure that thing really is a linked list. If it isn't, it will throw an exception. C++ will do nothing of the sort. If you downcast to something that is not a linked list, it will happily try to access it as a linked list and sake fault. Okay, Java garbage collects. So you do not do any explicit deallocation. You don't have to worry about the delete command anymore. Java will take care of that for you. So Java is going to do memory reclamation using garbage collection. No more memory leaks. Ha ha. Did I just say that? Why, yes, I did. So Java's garbage collection does, in fact, have memory leaks. You run a Java program long enough, say for a couple weeks, and eventually you will run out of memory and crash. Okay, so Java's garbage collection is not perfect. Memory is not completely free in Java either, although people treat it like it's free. Okay, so yes, there are not as many memory leaks in Java because you don't have to explicitly call delete. That does not mean that Java is able to garbage collect everything. There are things that have circular pointers in Java, and it will not be able to garbage collect them. And finally, I know it says one. Whoa, unbelievable. Are we behind me today? Great. Okay, mine says 155. We're wrapping up. Okay, no explicit manipulation of pointers. We'll get to that next time. You don't have pointer arithmetic. And the final thing I've already talked about, just-in-time compilers and hotspot compilers, but even with all of the optimization, oftentimes Java programs run a bit slower than C++ programs because you have all that runtime checking, okay? Runtime checking comes at a price. No matter how much you optimize the code, if you don't optimize out the runtime checking, it's going to run a little slower than C++. Normally, it runs within a factor of 2. These days, much better than a factor of 2. Some benchmarks show that the hotspot compilers can even beat C++ or C++ compiled code. Do you know whose benchmarks I think those are? Oracle's. Okay, so I wouldn't believe in general that a Java compiled program would beat a C++ compiled program because of the runtime type checking. Okay, remember there is something due on Saturday. That is the initial assigned readings. There's something due on Tuesday before class. Okay, but no quiz. Not until Tuesday. So read up, enjoy. We'll start deeper into Java on Tuesday.
Excuse me, Brad. Are these solutions you have up? Because it's the same name in the files.